Presentation that's a bit personal for me, because for 15 years ago I actually worked on standardizing this PEAP protocol. So I'm very happy to see that it has been completely broken, and this will be a nice demonstration of how. So welcome, Siarhei.
Hello, my name is Siarhei. I'm from Belarus. I'm a computer science student, the 4th year student. Today I'd like to present to you an amateur work just as an open source hacker. I've been interested in wireless security, and in this paper I was studying the way how man-in-the-middle attack can be implemented in the setup of WPA Enterprise standard when we use PEAP with MS-CHAP v2 protocol. The initial goal was like, I have discovered that I'm using unsecure, not secure setup of wireless communication, because at my university they stimulate you to skip certificate verification, just to enter your user and password, and that's it. So it's not secure because the history behind PEAP. PEAP, it is a protected extensible authentication protocol. It is based on EAP framework. It is a general conception of various authentication protocols. They all operate in the way of EAP state machines, just like a graph with vertices and edges, and each time the machine stays in some state, and getting a new message, it processes it and then goes into another state, taking some actions. If we will look at PEAP state machines, the RFC is 4137. In the draft, they proposed a conceptual implementation of state machine for client and the server, and there is a hostap project. You usually should be familiar with WPS applicant and hostap-D applications. One of them is used for client side, and the other one can work as a server-side application. Both of them share the same core, but they differ in the way who uses them. Why did I choose hostap? Because they had an example. It is called EAP example, and in there they configured a demo communication between the peer and server side state machines without any hardware layer. So we can just play around with it without setting up rogue access point, putting additional man-in-the-middle node. So that example, it has the exact setup. PEAP with MS-CHAP v2, without radius, just credentials were built in. And I wanted to simulate man-in-the-middle attack as it was written in the paper man-in-the-middle attack in, sorry, the name of the paper is Man-in-the-Middle in Tunneled Authentication Protocols. It is dated to 2002. It has been available at Spring publication in 2005, and on Wikipedia you are able to access it since 2013. And in previous year, I have studied to read it at first time, and it was a bit difficult to understand how to implement this man-in-the-middle attack, because it usually looks like this. These are mostly, it is written mostly the same way in that paper, just like man-in-the-middle, okay, waits for a legitimate device to enter an untunneled latency remote authentication protocol and captures the initial message. If you are operating in wireless networks, the previous step is to capture the attention of the client. It is called association. Usually, what can we use? We can create a rogue access point. We can make it to look like the same way as the legitimate server. That is, we usually configure the same SSID, and of course the inner protocol should be the same. It shouldn't be WPA PSK, it should be WPA Enterprise. And the second point, you need to get the client connect to you. If he is talking to a legitimate server, we can send the authentication packet to broke the session and ask the client to reconnect. Also, very useful technique is to come closer to the victim. This way, our rogue access point has the higher signal, and usually they prefer hotspots with a better signal, but it's not always. In general, it works. So we capture the attention of the client, it associated to our rogue access point, and at the moment we begin EAP authentication. So I have decided to call the server Alice, the client Bob. Usually they call eavesdropper Millery, but I have called it if. It doesn't matter at all. So in my simulation, the man-in-the-middle node, it consists of two if state machines, the if peer and if server. So if peer communicate with the legitimate server, and if server, this is our rogue access point that captured the attention of Bob. So actually, I think that they usually even make it another way with the names of Alice and Bob. Usually Bob is the legitimate server and Alice is the client. It differs here. So PEAP, it is a wrap over EAP protocol. Usually all those legacy protocols like MSCHAP-2, they send credentials with various problems. It can be weak password problem, like hash can be cracked. In 2012, there have been a talk about cracking MSCHAP-2 credentials in less than 24 hours. The platform is called Cloud Cracker, if I'm correct, and it utilizes FPGA nodes. In this simulation, I was interested in proxying the MSCHAP credentials from Bob peer to Alice server and backward. In January, around January 15, I have discovered that there was really cool paper in 2014 about not this trivial attack, but about really cool attack. It is called, okay, it's about WPA Enterprise exploiting, and they call proxying of messages like let use MSCHAP-1 oracles, because MSCHAP-2 protocol, it is the inner protocol in PEAP, and there is LEAP protocol that uses MSCHAP-1. And iOS 7 had a problem like you connect to the UDROM access point, for example, you provide your credentials, but if I will create a rogue access point with LEAP protocol, your iPhone will leak credentials, and even more, that protocol even does not use TLS tunnel. So if there is somebody interested in more deep study of the problem, you can refer to that paper. The link is provided at FOSDEM page. So in PEAP, at first, parties establish TLS handshake, the usual way. Server provides the certificate to the client. Client is to verify the authenticity of the certificate. There is no certificate authority, usually, because it's not good. It should be another trusted storage. The easiest way is to provide self-signed certificate into a client. And usually Android phones allows you to unspecify this certificate. This way you connect to the server without verifying his authenticity, and so man in the middle is possible. So we have established TLS. We have finished TLS handshake. It is a part of TLS protocol, and now we begin TLS communication. Both parties, Alice server and if peer, and the same is true for if server and Bob peer, they come up with a shared master key that is the basis for future encryption. So since we performed man in the middle, if peer and if server, they are in possession of both secret keys for tunnels between Alice server and if peer, and for the tunnel between if server and Bob peer. And now we are actually working with a pure mosttrivial protocol. Here I presented the actual implementation of proxying of the inner protocol, because it's not that easy to proxy the protocol. There are some things that differs. So I have decided to went into the code of hostap, and at first there was only 2 machines. I have created 4 machines. Then I added communication in pairs. These 2 communicate between themselves, and those 2 between themselves. Then I started to configure the setup. Like I disabled the verification of the certificate in Bob peer machine. Then I meet the following problem. We can skip the certificate verification, but we can be still sure that we were communicating to legitimate server. This functionality is called crypto binding. The idea is the following. We generate special integrity value with the help of hash function that takes as arguments both secret materials, the master key from TLS tunnel and a special secret key generated on the basis of mosttrivial credentials. And then we exchange these values, and both parties can be sure that the other end was in possession of both materials. And I was really trying to disable this functionality, because with it you can perform simulation. Crypto binding, they have been created in 2004 by Cisco, I'm not sure. At least in Cisco they had this functionality since 2004. And it's usually only for, it's usually only for PEAP v0, because in PEAP v1 they don't even have this crypto binding. So in my simulation I have configured PEAP v1 protocol, but just to make my life easier. So then I started to add communication between these two man-in-the-middle state machines. Like Alice server sends a challenge request to if peer. If peer does not have a password, even the hash of this password, then if peer starts a pending state, it's just specific functionality of the implementation hostap, and sends the data to if server. If server waits to the initial message from if peer and sends a challenge request, just putting inside the same data that was sent from ls server to if peer. Bob peer computes required response, if server obtains it, enters pending state, and sends the data to if peer. If peer successfully builds a forged MS-CHAP-v2 challenge response, Alice server verifies it, everything is okay, and sends success request. If peer have to verify this request because it is a part of protocol, but since it is an attacker, she skips it and sends the request to if server, because Bob peer won't skip this verification. So we need to deliver the success request to the end. So after that, the authentication is completed. Everybody thinks it's okay, I mean those ends. And we are, as attackers, in possession of required secret materials, and we are permitted to access network resources that were protected with WPA enterprise authentication. And as well, we can proxy application layer messages from Bob peer to ls server and analyze this traffic. It's very trivial attack. You can protect from this with the help of VPN, HTTPS, it works still. It's more about network resources, like some kind of university email or like that. So that's it. Thank you for attention.
Thank you, Siarhei. Questions? We have time for questions. Raise your hand. Yes.
How is the certificate normally checked against the host? So I thought about sometimes you get the CA from your university or something like this. Then does it trust them all certificates which are signed by the CA, or is there also a binding between the common name of the CA and the name of the radio server or something like this? So for the next step.
Okay. Usually you have you have to provide some kind of verification chain, like in usual trusted storage in HTTPS. In Windows, they usually mix these certificate authorities. In Linux, actually in hostap, you can provide separate certificates specifically for this network. The actual way how to